Well, hello, everybody, and welcome to today's training. I am Heidi Reese from Dayton Superior Marketing, and I have Chuck Hoke, who is our National Training Manager, along in the room with today's presenter that I will talk about in just a few. But before I introduce him, let's talk about some housekeeping items like we do every time to make today's webinar successful. So just a few items of note. The people that have signed in or called in have been muted so that the webinar can be free of other disruptions on the line and everyone can hear and enjoy it. But please feel free to provide any questions that you have throughout the presentation or at the very end. We'll have a mini question answer session. And you can do that through the Zoom chat functionality. So just go down the bottom or top, wherever your toolbar is, find the chat and go ahead and put a question in. And at the end, I will address those and then the people in the room and our presenter can answer the questions. So each of our webinars are recorded and placed on the Dayton Superior YouTube channel as well as our DaytonSuperior.com website. Just search for the product videos and you can find all of our past ones. This one will be out there a little later this afternoon and I'll send you an email to let you know when it is. So today we're going to be talking about threaded rebar splicing 101. So, we've only got about 25 minutes to make this happen. So we're really just going to be touching upon different splicing techniques, whether it's lap splice or the mechanical splicing, the DBR couplers, DBDI, taper locks. And then we'll go into some testing requirements and application uses. So let's get to the introduction of the awesome Matt Mayer, who is one of our technical service representatives in the splicing group. And he has decided to come and share his wealth of knowledge with us. Real excited. He is a graduate of the Texas A&M University and has been in and around the construction industry for roughly 15 years, dealing with insulation and fireplaces. And for about 10 of those years, he has worked with the rebar fabrication and concrete accessories. Matt is also a member of the Concrete Reinforcing Steel Institute, better known to us as the CRSI, and sits on the committees of the reinforcing bar fabrication for them. He also participates with the Anchorages and Splicing Committee and is a member of the American Concrete Institution group. We are pleased that he has come to Dayton Superior as a technical sales representative for the splicing group and spread his knowledge to assist our customers with the technical questions that he can answer. So without further ado, I'd like to give it over to Matt. And if you would let everyone know, or I can do right now, this presentation is intended for training purposes only. So if you want any specifications or anything mentioned in this training, please see DaytonSuperior.com. So Matt, go ahead.
Awesome. Thank you, Heidi. So welcome, everybody. Appreciate you guys joining us for this. We are excited to have you and excited to talk about some threaded rebar splicing applications. So like Heidi said, we've only got about 25 minutes. We try to keep these things short and succinct for you guys. So we'll jump right into some applications and rebar splicing 101, kind of the roadmap for today for you guys. We'll talk through splicing techniques and the differences between traditional lap splicing and the mechanical splicing that we're going to go through. And then we'll spend the bulk of our time covering our product portfolio just to get you guys familiar with the different parallel thread and taper threaded products that we have available to you. We'll go over testing requirements, applications, and some resources available to you guys. So like she said, if you have any questions, feel free to put them in the chat section and we'll answer those at the end. So splicing techniques, different options for you. The basic splicing technique that we all know and have seen for years is just lap splicing. That's very simply any type of lap is putting two pieces of rebar or any type of splice is putting two pieces of rebar together to try to make them work as one long piece. Lap splicing is the most basic. It's been around for years and it's very simply just placing them side by side and loop tying them together with either pigtails or tie wire. This is really good for flat structures like parking lots and pavement, sidewalks, those kind of things. But once you get into vertical applications where you get into bigger bar like number 14, number 18, it becomes very ineffective. And the reason for that is because it is very concrete dependent. So lap splices depend on the concrete that they are poured into to set up to give them their rigidity and their strength. But as those structures move, as concrete tends to settle or structures settle, then spalling happens and you wind up with issues similar to what you see in this picture here. This was just a simple transition point in this floor. But because of the movement and because of the various weights and tensions that were put on the concrete, the lap splice wasn't sufficient enough to hold it, and caused some spalling, caused some cracking, eventually caused a failure. So lap splicing, really good for flat spaces, really good for basic paving situations, but not so much for when you get into bigger structures and things that need more structural strength, structural integrity. One of the other things that you'll deal with lap splicing is congestion. I think if you've been on a construction site before, we've all seen situations where beams were intersecting and had multiple bars running through them with corner bars and different situations. The problem with this is the ACI has a requirement that architects and engineers have to adhere to of an 8% steel to concrete ratio. So as you're pouring your concrete, it has to be able to flow into all of the areas and meet that standard. When you get to congestion pockets like this, you'll run into rock pockets, you'll run into areas where concrete isn't able to flow, and that gets you outside of that ratio and makes the structure less sound and less rigid as it needs to be. So solution to that is mechanical splices that, as you can see, cleans up everything to make concrete easy to flow and easy to work with. It's something that's going to be real important here in the future as ACI and CRSI are looking at adhering to carbon footprint analysis that the government's putting in place, how much steel you have in your project and how much concrete and how all of that works together for the environment is becoming a big deal. So here you can see in these three photos just different limitations of lap splicing. Obviously for the steel manufacturers, these are great. On the right, we love to see that much rebar on a project, but as you can see, there's no way for concrete to flow through those. And then on the left, this was an attempt to do vertical columns with lap splicing. And as that structure moved and as that structure went through time, obviously those splices failed because of the movement. So the solution to this is mechanical splicing. The biggest difference between mechanical splicing and lap splicing that I can emphasize for you guys is how they are tested and how their strength is achieved. We'll get into the testing here towards the end of the presentation, but lap splicing, like we said, is very concrete dependent. Mechanical splicing is not. All of the mechanical splicing testing is done outside of concrete. It's done in a lab with just two pieces of rebar and the mechanical splice itself. So they prove that they can hold their strength and perform whether the concrete is doing its job or not. Mechanical splicing, very simply, is just the connection of two pieces of rebar with a sleeve, a coupler, or a coupling sleeve, and it lets those two pieces of rebar act like one long piece of rebar. There's 5 main technologies to that: the shear bolt, which would be like our bar lock couplers, and then the 2 we'll cover today that are taper thread and parallel thread. You've got grout sleeves that are real common in precast applications, and then you have swage, which is crimping couplers onto the bar. Here you see an example of a threaded coupler, and then this would be a shear bolt coupler. The biggest things to remember for mechanical couplers are 1, they're not concrete dependent. 2, they're governed by 2 types of specifications. There's a type 1 and a type 2 requirement for mechanical couplers. So those two types are listed out here. These are the very textbook definitions of a type 1 and a type 2. Type 1 has to meet 125% yield of the bar. Type 2 has to meet that plus 100% tensile strength of the bar. The easiest way to explain these and make it simple to understand is type 1 deals with how much a bar bends before it can't return to its shape. And a typical piece of rebar can bend a certain amount. When it's coupled, it has to be able to do that plus 25%. Type 2 deals with how much pulling you can do before it breaks. So how much tension you can put on a piece of rebar before it breaks. And when you put those two in a coupler, it has to achieve 100% of that tension. So those are all the technical things. We can get into some questions about that if you want to know more about that towards the end. But let's jump into our coupler system. We have our DBR coupler, which is our parallel thread coupler. This is a parallel thread that's cut into the bar. So as you can see there at the top, it takes a little bit of the cross section of the rebar out to put that thread on. But it is a UNC NC threaded system. Depending on what size you go, anything 9 and above is just going to be a UN thread. These can be plain epoxy or galvanized. They're just formed out of grade 60 rebar. Very good for forming applications. Really what these are good for with the NC thread is if you have a situation where you're attaching something to a structure via a NC bolt. If you're wanting to attach a sign or attach a guardrail or something, you would use the female end of this, which is forged up and has the ability to accept the male part. And you can attach anything to that structure using just a regular NC bolt. Very well known throughout the industry and very versatile in their application. They're good in rebar sizes 4 through 11. Meet ASTM A108, and we do have a coupler if you're looking to put two males together instead of using the forged female side. We do have the D50 coupler available as well, and that can come with a flange or without a flange, which makes it great for tie bar applications if you're looking at those. Next, we have the DBDI system. This system is, if DBR is version 1, DBDI is version 2.0. Very similar in appearance to the DBR system. It is just upsized. As you can see there, the males on these are forged upsized. Nothing on this is welded. Everything is forged together. And they create a type 2 splice for the connection. So DBR type 1, DBDI type 2, very similar price points, very similar applications. DBDI just provides a stronger connection point. One thing I'll point out with both of these systems and with the next system that we're going to talk about is all of these connections are hand tight. That's very important. It's one of the things that we're very proud of with all of our applications and all of our certifications. They're done with hand tight performance. So all you need is 5 foot-pounds. There's no torque wrenches needed. There's no crazy cranking on it with a pipe wrench or anything like that. The guys in the field love it because all they have to do is throw somebody on there, run them together, and they're good to go. Again, these are available in sizes 4 through 11, typically out of grade 60 rebar. We can do special grade 75 if you need that. And these can be configured however you need them to be configured. So if you need male, female, that's the basic way. If you need 90-degree hooks, if you need 180s, however you need them, just contact one of us. We can get those put together for you with whatever bends and angles you need on them. Typically, these are going to be used as a form saver application, and that's very simple. You just screw or nail the female side onto the form, pour your foundation, and then knock that form off, and you can attach the male to continue on with the next phase or the next pour that you have on there. We also have our D158 end anchors that go with this system. These eliminate your need for all the hooked bars at the end of columns and in the transition points between columns and floor levels. These can be done as a single end or as a double end or as a end anchor with a male, end anchor with a female. Really, whatever configuration you need on these, give us a call. We can probably make it happen. We're doing a lot of these in Texas right now with a couple of big projects that they have going on. And we're happy to get these put together for you whichever way you need. These can be done in a 5AB, which would be a 5 times the end, the head on the end, or you can do it as a 10 times if you have a seismic zone and you need those. All of this, again, forged, nothing on here welded, all one solid piece, and engineers tend to like that. There's just showing kind of different situations where you can eliminate hooked bars and make that a lot cleaner. We're seeing this design a lot more on the West Coast right now. So that is becoming pretty popular if that's something that you're interested in. Next, we have our taper lock system. This is what I would call the Cadillac system of our threaded couplers. This is essentially the way that I always explain it to people is we have a machine that is a pencil sharpener for rebar. It's a great machine, puts a thread on the end of the bar, allows fabricators to do this themselves. And all you get from us is the coupler, but it allows you to control the bends, allows you to control the production speed. The great thing about this system is that it is a type 2 splice, and that's for grade 60, 75, 80, and 100. So it does not matter what your project calls for. This product line can give you a type 2 splice for all of that. It's available with a full portfolio, and the machine can thread sizes 4 through 18. And again, no installation tools, no torque wrenches. These can be done in the field by anybody on the job site, just hand tight. These are great for bridges and high rises. You know, one of the things we talk about when we're talking about lap splices, and we say they're good for parking lots and pavements and things like that. They are not good for situations where there's a lot of movement. Taper lock and mechanical couplers are good for situations where there's going to be a lot of movement. So bridges, especially where you've got cars going over them every day, all day, is a great situation to put a coupler like this in place and not have to worry about the strength of the project. This is the machine that we were talking about that threads the bar. We place these around the country in various fabricators, and all of this is enclosed. All the action in the machine happens right inside that compartment where you can see the windows. It's very simple. You just insert the piece of rebar, punch a couple of buttons, the clamps inside clamp down on the bar, and the thread puts the desired pitch on there for whatever bar size you have. You can see on the left how fast that machine is. It is the fastest one in the industry at this point, and the safest one. None of the operation happens outside of the machine, which means that all of the guys in the shop are kept completely safe from any moving components or mechanical dangers that would be present on other machines. As far as the portfolio for taper lock goes, we'll run through this real quick. We have our D310 taper lock, which is just like the D50, except with a tapered thread. It connects 2 pieces of rebar that are the same size. So anytime you've got a long run and you're just looking to connect 2 pieces of bar, D310 is the way to go. We also have our D320, which would be a transitional. So this allows you to connect 1-step transitions. So if you need to go 5 to 6 or 6 to 7, commons, you'll see your 8 to 9 applications, or 10 to 11. We see those 2 different sizes pretty frequently. This will allow you to connect those 2. If you have different size bars, typically as you're moving up or down a column, you'll see those situations. We have our D330 positional. This is used to connect 2 bars of the same size, and it allows you to rotate those bars into a position. If you have hooks up at the top of a column that you're looking to rotate into a specific place, you can use it as that application. Or if you're looking to connect 2 column cages and your bars aren't quite fitting together correctly, if they're not quite moving into place properly, this is a great situation for a D330. It allows you to connect those 2 bars via the movement of the coupler. We have our D340, which is our flange coupler. This is used really strictly as a form saver coupler. Very similar to what we talked about with the DBDI. You would just nail it onto the form and pour it in place. It used to connect bars of the same size. We don't have this in a transitional. And then we have our 350, 351 end anchors. Again, the difference between the 350 and the 351 is just the size. The 350 is a 5 AB. The 351 is a 10 AB, which just means it's 10 times the bar diameter. These are great for footers, column to slab connections, anywhere that you need to eliminate some hooks, anywhere that you need to be able to put an end anchor where you have a lot of congestion, like you can see in the pictures here. This eliminated a lot of hooks on this project. This is actually up in New York. Those are all grade 100. And we put a couple of thousand of these on that project. We have our D360 weldable. If you need to connect rebar to structural steel on an industrial project, that's a typical application. This allows for that. It's got a slight chamfer on it, and the engineer will specify what type of weld you need to put, and then you're able to just connect your rebar to your steel. And that is the portfolio as far as our parallel couplers and our taper threaded couplers go. Again, I know I ran through that pretty quick, but ask some questions at the end and we'll be more than happy to stick around and cover it. As far as the testing that these go through that we've hinted and alluded to a couple of times, we've got several different agencies that we have to comply with. Most of our stuff is on, there's about 35 states that have QPLs or APLs that deal with mechanical splicing, and we're on almost all of those at this point. We also comply obviously with ACI, CRSI, Caltrans, PCI, AASHTO, any of those regulating committees we are either a part of and make sure that our couplers comply with. The two biggest test methods that you're going to see are the monotonic tension test and compression test. You also have to go through a cyclic test. If you're in California, the rebar has to go through a 30,000 cycle test of pulling and pushing to make sure that it can withstand the tension. In Texas, you've got to go through an 80,000 cycle. But all of the couplers, it doesn't matter what type, if they're just the DBDI where you thread the two pieces together, or the taper lock where you've got a coupler in the middle, or shear bolt couplers, sprout sleeve, any of those, they all have to go through the exact same testing to be certified by IAPMO, and most of them require a third-party testing. So where you can utilize these is really, I mean, I know it sounds juvenile, but anywhere there's concrete. You're welcome to still utilize lap splicing in parking lots and sidewalks, but if you've got a structure like this, a stadium that's going up, you've got elevator shafts and ring beams and parking structures that are going up multiple stories, you really want to be considering mechanical couplers for that project. High rises, you'll see these all up and down columns. The core wall applications are huge for couplers. We've got a couple of high rises going in Houston right now that are using these all through the columns between the parking structure and the building itself. Water treatment plants usually have a significant number of form savers on them, usually have a significant number of connections that need to be taken care of. And you can use DBDI for that or the taper lock system. And then bridges, obviously, we've touched on a few times. Anywhere that you're going to have a precast connection, anywhere that you're going to have a lot of movement in a structure, you really want to be using mechanical couplers as opposed to a lap splice. So resources that are available for you guys, we've got a couple. We do have a splicing selection guide. This is just an easy, quick reference chart that we've put together for you guys. We can send this out, just request it, and we can send it over to you, let you kind of do a cross-reference of what your connection is and what strength you need, and allows you to put those together. And then we have, obviously, on DaytonSuperior.com, all of our technical data sheets, all of our resources available for you guys. and the ability to reach out to myself or my counterparts. If you have questions on splicing, I have a counterpart in the West and the East, and we're more than happy to come in and have more discussions, do presentations, whatever you guys need. With that, I appreciate you guys, and we'll open the floor to questions.
Yes, excellent. We've got one from Fondelier. Tim says many DOTs are allowing what was considered a type 2 coupler, the DBDI, the bar lock, L taper lock, 160%, to now be listed as the ultimate connection. What changed is the question.
I would have to do more research because I haven't seen that in a few of the DBDIs that DBDIs, a few of the DOTs that I've dealt with. I do know that typically what they're talking about when you talk between a type 2 connection and full ultimate is really just dealing with the tension of the bar. And so it has been a discussion point for the last couple of years about what was the difference between a type 2 and a full ultimate. And it sounds like that's becoming just a industry standard to call it full ultimate. But Heidi, if we can get contact info, then I will follow that up because that's a question I don't know the answer to off the top of my head.
Sure thing. All right, is there any other questions? If so, go ahead and put them in the chat functionality and we'll get them out there. While we're waiting on that, if anyone has any questions, I do want to thank you for joining us, as Matt had mentioned. Remember that we have these topics every Tuesday on different topics. They're always at 1 p.m. Eastern Standard Time with usually different presenters of our different experts, whatever the topic may be. Give it a little bit more if there's any questions. So once again, today's presentation has been recorded and will be available on the training site located on DaytonSuperior.com, as well as our YouTube channels. That will happen a little bit later on this afternoon. Let an email go out to you guys. I'll also include the splicing selection guide that was referred to 2 slides ago as a link, so you can get right to that if you want to. All right, and if there's no other questions, then that should do it. Thank you, Matt, for presenting. Great job. And thank you, everyone on the phone, and have a happy Tuesday. Bye.